Yeah, I think we can start our program for today's session. So I am Dr. Lakshya Zwala, Associate Professor in the Department of Physics, Pachu University College. So I welcome every one of you on the third day of this international webinar on integrated approach in science and technology for sustainable future. So as we all know, this program is organized in commemoration of National Science Day 2022. And as we announced it earlier before, in the previous two technical sessions also, this program is jointly organized by Research Committee Pachu University College and Mizoram Science, Technology and Innovation Council. And here in Pachu University College, the chairman of our research committee is our principal, and Dr. Lilian is our secretary, and Dr. Kevanal Dinpuya, who is the coordinator of this international webinar, is the assistant secretary of this research committee. So as communicated to our uh, invited speaker for tonight, I think the team and all, the program and all is already known to every one of you. And here we are delighted to have this very renowned person like among our Mizo community, Dr. Lilian who is scientist C in Wildlife Institute of India, and Dr. Krishna who is assistant professor in the Department of Physics, Banaras Hindu University, UP, for the technical session on the third day of this technical session in international webinar. So on the first day that was held on 7 March 2022, Professor Senthil Kumar, Dean School of Life Sciences, MZU, was the resource person. And the second day, which was held last night, that was on 9 March 2022, Dr. Judith L. Pachua, who is a senior coordinator, research quality, MD Anderson Cancer Center, USA, was a resource person. So on behalf of the organizing committee, I welcome our renowned speakers who have given their consent and share their valuable time for this event to be successful. And also in this webinar, as you are well aware, our institution is an undergrad as well as postgrad institution. So we cannot accommodate all the students in our Zoom license. So only the 6th semester students of science departments like statistics, botany, biotechnology, zoology, chemistry, physics, and mathematics undergrad students are expected to join this webinar live session in this Zoom platform. And in addition to the 6th semester students, the postgrad students of MSc Life Sciences and MSc Geophysics, they are also expected to join. So hopefully, I think the attendance here in this Zoom session also will probably cross 130, 140 later on. So, in addition to this group of students, all the science department students are also expected to join the session through YouTube live program. So whatever the program we are having tonight, it will be broadcasted in our college YouTube channel. So the rest of the students will be joining the session through our YouTube channel. So as I mentioned before, we have two speakers. Our first speaker will be Dr. Lilian Kolni. So yeah, I have heard about her. I think the time when she was selected as a scientist, way back in 2018. She was in the news, and she was not only in the social media news. She was, I think, her achievement was published in our state newspaper, also Vanglani and other newspapers. So I don't think we should spend much time in introducing her. She doesn't need introduction, in fact. So as far as what I can gather here in the news, in a news website, she is now serving as a scientist C in the Wildlife Institute of India. And this Wildlife Institute of India is under Ministry of Environment, Forest and Climate Change, Government of India. And it is located in Dehradun. And this is the premier wildlife institution in India, probably the only one, I think the one and only, or probably, yeah, this is the best. It might not be the only one wildlife institution. I'm sorry for my lack of knowledge in this matter. And this is the place where Indian Forest Service, IFS, and State Forest Service people, they go for a training. And in addition to conducting the training courses, they also have MSc and PhD program there. So not only that, they are actively involved in research as a scientist, they are also a teacher there, right? So Dr. Lilian graduated from CVSC and AH, Central Agricultural University, Selassie Aizawl. I think that way back in 2011. And then later on, she finished her MVSC, Master of Veterinary Science, Wildlife, in 2013. And then after that, she served as a faculty in the Department of Veterinary Microbiology, CVSC and AH, CAU Selassie Biotech Hub. And she was also involved in transboundary disease project. And then after that, she was recruited as a scientist C. So as far as my knowledge is concerned, I think she is the only female scientist among Mizos. Working as a scientist C in the Wildlife Institute. And yeah, I also Googled her a little bit, as I will be the chairperson in this session. So I have seen her interview as well in the YouTube channel. So I think it is very wonderful to have such a successful and successful Mizo woman as a resource person for today's session. So without spending further time, I think I should now invite our resource person to deliver her speech.
Okay, good evening, everyone. Thank you, Sir Shadzwala, for the very kind and very elaborate introduction. First of all, I would just like to say that I'm not a successful Mizo woman. I'm a successful Mizo, okay? Leave the woman out, please. And secondly, I want to know how much time I have.
Usually it's around 1 hour. You can deliver, right. Yeah, if you can finish it up within 1 hour. Then after that, we can have a discussion also.
Okay, great, cool. Thank you, everyone. So good evening, everyone, and to the moderator and the dean of the college and everyone present here. I wish you a very good evening. I hope you had a very nice day, because, you know, after a long day, we're all back online and trying to listen to some talks. And so I think we've all had a long day, so I'll try to make it as interesting as possible. I'll just share my screen. Yeah. Is it visible?
Yes, it's visible.
Yes. As we all know, the theme is an integrated approach in science and technology for a sustainable future. Now, I'll just reduce this. Sorry. Huh. Sorry, it's slightly hanging. Just bear with me a little bit. Yes. So I'm going to talk about something very interesting, which is going to be very applicable to everyone who's attending this, regardless of which department you're in, regardless of which branch you're studying, regardless of, what, varied future prospects you're thinking about right now. I think that this is something very relevant to every one of you. And maybe after this presentation, my main aim is to, how do I say, stir up your thinking as to how on your respective branches of study, you can contribute to this sustainable future and for the sustainability of the environment. All right. Now, I have given my topic as One Health, the road to sustainability. So I don't know if you have heard of One Health. It's not a very new concept, but it is becoming popular very recently due to the COVID pandemic, due to emerging diseases happening here and there. So it has gained a lot of popularity recently. All right. So, but I will explain if, because I think that mostly we are in the general sciences. So one might not be too familiar with the word. So we'll have a brief introduction of what is One Health first, and how are we relevant for One Health? How is our subjects, each of our subjects relevant for One Health? All right. Now, we know the term biodiversity, right? Biodiversity just means, in simple terms, it just means all the living diversity that is in the on the earth, right? Now, it just means a variety of life forms, right? Now, the earth have existed for such a long time, right? Evolution has occurred, the earth has existed, whether you believe in creationism or you're a creationist or you're an evolutionist, doesn't matter. The earth has been there for a long time, all right? Now, now the number of species on earth, that is the biodiversity, is tagged at around 8.7 million, right? Now, but we have seen a lot of species and some life forms being extinct, and we should know at first that extinction is a very natural phenomena. It's happening and it will happen. But right now, in this present time, why are we so bothered about extinction? Because researchers have classified this as the sixth mass extinction, which means that the extinction rates are 100 to around 1,000 times higher than the usual, right? So that becomes very relevant and important, right? That it becomes a cause of concern. Now, we were talking about life forms and biodiversity, and I have mentioned that the number of species on Earth is tagged at around 8.7 million, all right? Now, we would think that such a numerous amount of diversity, how could we possibly be so intricately interconnected? Which is how I would like to, every time I think of that, I give this analogy of the spider web. Like, for example, when you see a spider web, each strand of the spider web is connected to the other strand, right? And each strand supports the other strand. And when each strand is intact and is supporting each other well, then it becomes a good home for the spider. And the spider can live there, the spider can, lure its prey there, it lives on, right? As long as the spider web is intact. But now, so each species and the forms of the biodiversity forms on Earth, let us represent it as one strand of the spider web, right? And like each strand of the spider web is interconnected and is supported and is supporting each other. we also, each life form and species, we are supporting each other as well. Now, like the spider web, when one strand of the spider web breaks off, another strand or the other will support it, right? So that, it will still support, so that it will be able to support the spider, right? To live there and to thrive there. Now, but if too many strands are cut off, or if too many strands uh, 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 break off, then the amount of stress on the intact strand becomes more, right? The amount of stress that is supporting the strand that has broken off becomes more. And ultimately, it becomes, unfit for the spider to live there, right? It renders the spider web unfit, okay, for the spider to live there. Now, just like that, we are also like each strand of the spider web, we are intricately connected, we are supporting each other. And just because one strand breaks off and there are extinctions of plant or animal forms or mammalian forms, then we think that we're still living, the earth is still going on. So, it's not a big deal, but it's not so. If you look at it more intricately, just like this, the pressure on the unbroken strands are more. So ultimately, it will render the place we are living in also, the planet we're living also, unfit for survival. Okay. Now, this is where the One Health concept comes in. The One Health approach brings together all relevant sectors and disciplines across the human and animal environment interface in collaboration. All right. That is more effective, so that it will become more efficient, so that it will become more sustainable, than might be achieved without the shared goal of improving health for all, for both humans and animals, and not only that, for the environment. Which means that we have this human entity, we have animal entity, we have environment entity. The One Health concept brings together all these entities, and it says that, all these entities cannot work together independently. There has to be a holistic approach. All right. So now the factors responsible would be like so many things. Okay, like habitat destruction, habitat degradation and fragmentation, climate change, emerging diseases. Like, now it's so relevant. We were public health professionals, medical health professionals, and veterinary health professionals have been talking about this, of emerging diseases, but it did not gain so much popularity among the common masses until the recent COVID pandemic. So now I think it's more relevant than ever, and everyone and each one of us are aware of the consequences of this. So it cannot be ignored or, overlooked anymore. Now we have wildlife trade, we have environmental pollution, we have movement of people, of animals and animal products throughout the globe. And we all know that now the world is like a global village, right? So now all these are due to the exponential human population growth. Now, because of all these, we need to, how do I put it? Like, for example, when we talk about sustainability, the first thing that usually comes to our mind is the survival of human life, right? But in order for the human life to survive, we need all these other life forms, and we need all these abiotic and biotic factors, and our environment in a healthy state, right? That is One Health. Now, so as we can see, all these factors responsible are also very much intricately interconnected, and we cannot take one apart from the other. All right. Now, if you see this is a picture, a satellite picture that is taken in 1992 and 2009. Okay, the left side is the one taken in 1992, and the right side is a one taken in 2009. These are night lights. If you look at the difference, you can see how exponentially, human population is growing and humans are encroaching into uninhabited areas. So over here, even though it's not really wildlife conservation per se is not part of my talk for tonight, but I would just like to point out that just can you imagine, like, all these dark areas are uninhabited areas. So it doesn't necessarily mean they're forested areas either. They could be barren lands, or they could be they're just uninhabited. I'm not talking about whether they are forested or whether they are untouched. All right. But as you can see here, if you can look at these places, and if you just imagine where these protected areas are situated, you can see that there's going to be a lot of stress on these free-ranging wild animals for their movement, right? Because they also have behavioral patterns, they have their own behavior, and they have their own ecology, which they have to follow and live by. So you can think of how it's going to be difficult for these animals to move about and perform their maximum ecological role, right? So so this One Health becomes even more relevant, because we call it the interface. Okay, the interface means that where humans and wild animals, are overlapping or are meeting. That's called the interface. So due to this rapid growth in human population, we are causing all these factors which I have mentioned in the earlier slide: habitat degradation, pollution, interface increases. So it becomes more relevant than ever. Now, so when this interface increases, these issues also tend to flare up. Now, these One Health issues, mainly I have just classified some main points which might be relevant to us and which we might understand. There are also a number of other sub points that we can talk about, but for tonight, let's concentrate on these. All right. One are zoonotic diseases, which can be transferred from humans to animals and animals to humans, right? Regardless of whether they're wild animals or they are domestic animals. And the next is antimicrobial resistance, which is now a global concern. I don't know if you have heard of it, but it's now a major global concern. Public health professionals are worried about it. Everyone is worried about it. Okay, so when we talk about antimicrobial resistance, it means the ability of this pathogenic organisms or bacteria to inhibit the action of antibiotics. Okay, so it becomes so this is now a global concern, and it's really, really life-threatening, and a lot of people die of antimicrobial resistance each year. Now, food safety and security, okay, are also One Health issues. So when we talk about One Health, it doesn't only mean about diseases. It doesn't only mean about the intactness of the environment or a forest or something like that. But it also has to do with a lot of economic stability. It has to do with food safety. It has to do with equity. It has to do with equality. It has to do with all those things. Everything is interconnected here. All right. Now we have also vector-borne diseases. Now vector-borne diseases are mostly used to be diseases of what we say tropical areas, but now it has increased to many other places as well. So it's increasing. So this is now also a cause of concern. And in Mizoram in Heran Nung Second Ang Siang Kamo Hemi Randung ina anpai ang sikat yang vector-borne diseases ang si ang ka anita hey malaria ang tepon yang. So all those kind of diseases, those are flaring up because of all these issues, all those factors that I have mentioned in the previous slide. Now we also have environmental contamination, and all these can be toxic contaminants, pollutants. It can be household waste, it can be industrial waste on a larger scale, it can be oil spills. It could be any type of environmental contamination. So I just want you to open up your imagination and think of that. All right. So I have told you all the issues that are involved with One Health and all the factors that are giving rise to One Health issues, the One Health issues that I've mentioned. And now, how does the One Health approach works? Now, as you see here in the picture here, you can see all sorts of things. Like you will see here the environment. These are the sectors and disciplines. We have animal, we have humans here. Now we have society here. We have a rural community here. and all those things are here. And over here we have uh, a healthy ecosystem, healthy humans, and healthy animals, right? Now, how does this One Health approach work? It will work by involving experts in human, animal, and environmental health, okay? And when we talk of human, when we talk of animal, and when we talk of environmental health, you can just imagine what are all the branches of studies that are responsible or involved in each of these entities. So I think all of your subjects, regardless of whether you're in life sciences or you're in chemical sciences, it's all relevant, right? And other relevant disciplines and sectors in monitoring and controlling these public health threats, and to learn about how these diseases spread among animals, plants, and the environment, all right? And in order to have healthy humans, so that means we need healthy animals, we need healthy environment, right? So if we're going to have a healthy environment, we need people working on environment, right? In order to have healthy animals, we need people working on animal aspect. If we need healthy humans, we need people working on the human aspect. But all these cannot work in separate entities. We have to have a holistic approach. Now, successful public health interventions require the cooperation of human, animals, and environmental health partners, like I just mentioned. Then professionals in human health would be doctors, nurses, public health practitioners, epidemiologists. Now we are talking about molecular diagnostics. So even biotechnologists and all those zoologists can come into this arena. And we also have animal health, in which veterinarians like me, paraprofessionals, and even agriculture and horticulture workers are also involved, right? And we have the health of the environment, in which ecologists, and we have wildlife experts, right? All those people are involved. And also, obviously, we need other areas of expertise like economists, all those kind of things, social scientists, historians. We need to communicate and collaborate on and coordinate our activities. Now, other relevant players in a One Health approach could include law enforcement as well. And it has to include policymakers, because all these things that, the science that all these entities, the science and that we are culminating, need to translate into policy making, so that it can be applied to the population, okay, to the human population. Now, agriculture, we have communities, and even as your role as a pet owner, you become very relevant when we think of it as a One Health concept. No one person, no one organization or sector can address issues at the animal, human, and environment interface alone, because now our interface is too much. Like the nightlight map that I just showed you from 1992, the difference from 1992 to 2009, right? So this problem is our problem, regardless of which branch of study we are in, regardless of which community we are in. We are all a part of this. So we are all responsible for it, right? Whether we choose to contribute to improving these problems based on our professional work, or regardless of whether we choose to address these problems personally in our personal life, in our like a social work or a community work, we are all relevant, right? And especially as educated, professional people, and you're all undergoing higher studies, you become even more relevant, because your education and your expertise would mean so much. It could translate to so much improvement for those kind of to tackle those kind of issues and problems. Now, I just wanted to share with you. Sorry, my screen keeps getting stuck. So I hope we are clear about the One Health concept now. So and I hope I made it at least a little bit clear as to how each of us can contribute to it. I mean, there's not really enough time to actually dwell on each subject and how each person or each interest could be, absorbed for that. But I think at least I have opened your, imagination and thinking as to how you can contribute to it based on your relevant study. All right. So now I would just like to talk to you a bit about what, on my part, like some of the works I have done, we have done actually regarding contributing to One Health. All right. So if you, as I go on to talk about it, you will realize that these are also very, it looks like some things like the subjects are stark different. Okay. There's a stark differences in each of the works that we are doing, but all these actually, it helps in One Health. And so I think that is how, maybe, how do I say, can help you think better how you can actually translate your subject in your line of study to words sustainability and the health of the environment, and ultimately the health of the humankind. Okay. Now over here we have this thing we have done, like that antimicrobial resistance study I have mentioned to you before. Antimicrobial resistance, I mean, so we are undergoing one project which is called the population management of species involved in human-wildlife conflict. We're working in many different areas of India, and one such work we're doing is in Karnataka. And so within that study, we're doing some sub-studies. Okay, so one thing that was interesting to me was like we are studying conflict, which means that wild animals are ranging into croplands, agricultural lands, they're destroying the crops. How are we going to mitigate that? How are we going to help the farmers? How are we going to slow this down? How are we going to prevent it, right? So that is the main aim of the project. However, there was one thing that I was thinking of, and like I'm really proud that that this is something that I'm proud to say, I thought of it. So one thing is this antimicrobial resistance profiles, and we did this molecular phylogeny of this some bacteria. So in South India, they maintain these elephant camps. Okay, so these are normally rescued elephants. And so these elephants are also let out in the wild. All right. So taking this as a surrogate for, wildlife, wild animals. All right. Like I said before, the entities of One Health, wild animals, that is the environment, domestic animals, and the people. All right. Because they are also roaming into the forest. They are there with human beings because they are taken care of closely by their caretakers, which are called mauts. So each entity is, I felt that was well represented, so it kind of acts as a surrogate for environment, human, and animal entity. So we kind of like did a study on this antimicrobial resistance profiles, and we did a molecular phylogeny, and we got very interesting results. So that is one thing. And so it shows that, these antimicrobial resistance are also circulating in the, probably in the wild, because we know how bacteria are transferring all these things. So it gives us a more clearer perspective of what is going on, what is going on around us. Okay, and the magnitude of this problem. Now, the next thing is that it's under the same project that we're doing. So there's a lot of conflict problem going on. Okay, in Mizoram, we're not really aware because we don't have that much wild animals. I mean, honestly speaking, we do have conflict cases like, or Savomina Seam or Katiang Sazu in a low can do an Azawati ang Siang Katsukan Navy Tota, Masi Abak ang Katsu, hey, puntanga viramaten de ang hian kan nei ve tak tak lo ni chu viramate pe chanin they destroy in acres and acres tuna khanin thamasa khan West Bengal kakala hemi human wildlife conflict chu changa hadin an jalda para boro akhan an nei na sa MMA ni chan chu ta chanin I en lo ani chu he tea estate tea plantations lian puian nei chinta he asum shompo na ni chu ni ho sa pui nan nei chinta ni I chuan I South India khwanin hun pakhata I chutiang ang chu I hemi tunakati immunocontraception ang chi kan apply na to hi ombokta chuta po chuan he enge coffee estate zau lutuk lian lutuk ang khanita he enge company lian deu te pon om ma se I can't mention it right now the name ma se khatyang ho te in an om na khanita khatyang a khanin I sai te sakei te khatyang kha anon om ve tla chini achan chu historically that's their habitat an om na chin khani tla tawangin khang tiang a khanin boin tam takan tok china ni elo virama phi chu Mizoram kan na to hi chu ane blutuka but we are very very intolerant on animals kan a case hi claim he ma say we are so intolerant on animals he hi chu kanin siam that na to pakhat aning ka shepoka chang thar te kanin siam that tuling ka sha chu wangchan voina hanin he ka soitel du zwai ani chu hun dang te khin phe chanin a magnitude le inge a frequency kha ala claim tu ni chu conflict kan nei te po hi mo ramsa te kan ho em moti me to han case pakhata oma machine khan khongai thak lo an laina umlo kati na ani lova amaro chu case pakhata oma aramsa pum pi kan hwa moti me to na achang phe chang kan va thata mo akhono ten kan kala kan va vea khatiang tur kha ani lowani so here, the main purpose of this immunocontraception is that it's a humane way to control the population of these animals, right? So there are also animals which are overpopulated or isolated populations. And tiang chi khan beta omzia chu population kha hun pakhatia khanin an ombi khat ve china ni chu achang chuan achan chu an mani range na tur an kal chwa na tur kha ponga om to lo wagin ikana nin thapung chak pasia kha boina siam ve china ni tuna po chumi lo lia chuan thil dang lia chuan he zong kan sianga rhesus macaques ang chiang hi virama chuan nan tam em in shepe ka ngai kalvek tonga khang tiang ho te kha I khopuya te khopmi lo a po problem tam em ani I amaro chu I kan unau namdang ho te hianin tina ta va tha ti rem ang chi an she em bang hian state chen khada chuanin shoot to kill permission te po an nei vek ani vermin angin an classifier shoot to kill permission te po nei vek amaro chu an ti khan har salut wan ti du lo ani chu chuwan chuanin sarkar khanin he claim a humane way mo an mani behavior inge effect lo tu si kha inge thiang ti kha an zong ta chu ta chuanin kan institute hi hamia hanin inge anodal agency kan ti me ang chu lai kha a responsibility khan ron peta chuan he immunocontraceptive vaccine hi man kan tum ta ni so how it works is that we take this zona pellucida from the ovaries of pigs and make a vaccine out of it, and we give that vaccine to the animal, and so that inhibits the fertilization. It blocks the spermatozoa from entering the sperm receptors. So that is how it works. It is completely reversible, and it is not permanent. It is completely reversible, and it has been used in other parts of the world as well. Okay, in Africa and in North America also it has been used. So this is something that we are trying to do. These are basically the other contraceptive vaccines and their commercial names. So these are interesting things also, like as a zoologist of endocrinology te inzirna sa katakanin he katyang siang ho kachu reproductive endocrinology at tuitan page on het yang anti tu tam takha omani so wansadin if anyone is interested intern to tepon mapon pusia kasoi tepon kasom to china khangkha all of you are very much welcome. Interested in omswan chuan heng tiang te po hi thil poi mo lu tu kanita I project lian tham ta kanya enge a success le failure tur hi India han kan le shi thiam lo ma se kan han test anga enge andon ni so tuna hanin it's undergoing right now. Now thil dang le we were talking about reproductive endocrinology, and I'm going to talk about something much different. All right, this is about assessing the health of an environment in a sense that, you know, I believe that ungulates are so important. Enge mizoa chuanin enge ungulate kan ti chuanin hey hoofed animals kan ti ang chi hinitani chuan enge poi mona kan ti chuanin enge atlang win carnivore mo apex predator ho cholom kan ti chinta ma se khang tiang remote khani lawa an mani hian ecological engineers and ni chu I seed dispersers ten ya anwa kwala thilan ea thayan ea thingna thingpar ten ea tikhanan kalkwala tikhanin forest health kha mo kan ramngote chisel na kha kha an maintain ani chu an poi mo lu tuka chuta chuanin I hemi ungulate study te hi kan han ne ani chuan I enge an activity pattern te kha kan ka student pakhat hian I da ron zira I ama hi WIS student khanya chongte khwami nya tuna chana master si zo to a chuan an activity pattern te kharon zira ti khan he seronia he barking deer he sambar mo chuan chu enge human activity antina na mishing chu enge ramhwai te khan valu chinta kaka human activity le an activity pattern here human activity khan mishing disturbance khan ati boyem khoilange peak activity ne khoilange an nei lo intinge kan ti ang ti kha khang kha a en na ni chu chuan khang kha khami information kha khang kha apoi mo em ani he his wild boar tanya he sele tananya chuan khang kha hemi information kha enge activity pattern in shani mailom ti remote khani lawa intinge he kan prevent thiang intikange mishing te hi lut lo se thang intinge kan disturb ti kha khang information kha apoi mo em tania result kha khang kha heta wildlife managers te forest officer te na khadin information poi mo tak khanya an ni khanin khami kha policy decision making atante an management decisions atante khan an lo mang don tina ni chu khang kha poi mo em ni chuan he relative abundance index kan tia e chu antam anzat tina ang dewani me chu an relative abundance ang khani ta chan he AITM ka All India Tiger Monitoring anya All India Tiger Monitoring chu initiate karinga soina hun om tolonga hun ka mangrei to inga. So this is basically just us comparing that All India Tiger Monitoring report in 2018 and our study in 2021. So hey barking deer population tekha he apol hi kemani study nita sen hi orange AITM report khanita khanga khadin inge atlan yam ni atla asang zo tekha kan enani chu chuan adotlia chuanin enge an abundance ka influence ti kha kan ena mishing activity le enge mishing omna human habituation te human activity tamna te khan affect them ti te kha kan ena nge elevation nge ground cover te na affect them khoi nge en model ber hi nge thaber an abundance reflect to han ti te kha kan ena khang te kha to management decisions yamna khan hilpoi mota kani tu na chuanin kapsu thinkit su ti remote lampang kha ani to lava ta soi to ang khan exponential human growth awang han thil tak problem kha tan om tup me ni ashana lakshan ti to ani bok si lo chu wang chanin thil kan ti reng hi strategic scientific strategically informed ani angai to awang in heng tiang hi apoi mo em ani chan he te hi sambar tanania chan sambar khachu enge human disturbance khan nasa takin negative in affect ani ti te khakan hu chwakta chuanin enge luite omnge luite omza te khana effect them ti te elevation ti za tinge effect ti te khang tyang te kan enani chuanin entina na community le social worker tweet tan po entina he economic sociology lampang ang zirte economics lampang zirte commerce lampang zirte tan te po khanin conservation le hemi health of the environment anga in sustainability atana hemi indirect subject ang si heta textbook ang si anga in zir nilaw kan heta aron apply thi na kha aom be kani tuna puan hemi community ge and lohan social survey kan tia chan heng tiang te hi enge hi dampa ni ta hi surrounding villages anita ni. So what I always would like to mention is that these forest communities are really, really important. They are a part of the environment. They are part of the ecosystem there. So we need to respect them. We need to respect their livelihood. We need to respect their opinions. So wangtag swanin heng village communities te hanin kang tiang tui chi ang khatswanin thilti tu tam tak oma enge anmani questionnaire tanga zir chiana te kha kan neya chuan kan han zir chiana te khanin enge ka student pahni te pakhat chu WI student vevenya pakhat chu junu chakmania pakhat kha ani chu wildlife science student ania pakhat chu valpuya enge heritage and conservation student anita
चला गया
Excuse me, please mute yourself. It's interrupting. Please carry on.
Sorry. So anin I kha khilai nge ka soi kha. Oh, okay. So anin kha moro
student ni sai
oh
Student
okay, thank you, Krista. So what we are conservation and natural heritage MSc around WI kha enge kemani natural heritage lampang kan cultural heritage kan food habits lampang kha le conservation in link na kharon zero bokan chu interesting lu to kan study hi dampa streams te kha dan a survey ya tikhan he enge amphibian species more frog species anurans kan yang chi anuran species kan yang chi ho te kha ka tyang te kha zir chianga khang tyang te kha ron ena kan ke ma hian in ka du dan chuan in hetiang kan food habits te kap su e su ti riwat lampang ai chuan in engtin nge sustainable taka kan culture le kan namzia rang ichimit si lo engtin kan culminate thiang ti kha apoi mo ka tia chung chu khang ang information khan ron ena enge field studies tu na ka ti ang te khatiang ang tam takan ron ti ba ka khan questionnaire survey te community work te po hi anti tel bukani chuan chu ta chuan in he awai the share don lo chan chu kan la publish cha lo wangin ma setlem te kan khila yang chu he hi enge an ho te simple de wanya he hi chu an meet preference te kha kan zota ti khan enge wild meat preference enge nei ti te mo khatyang species as ten chuanin heta karon share thelo tam tak information kha oma amaro chuta chan makdeu enge result kan hu ve chu a chen khanin he enge tuna chuanin thang tharte chu kan lekha ten lo thiam zo ka nge khovel tu vera kan hoi zau zo ka chu bangin conservation te po du zok tur anga in ngai na lai om lai khan kan result da khachanin khatiang khan alo ni kher lo ani chu thil tam tak social factors te economic factors te kha aron play te chi ata ni kha aron play te chi ata a om zia chu kan a upalam te khanin apui mo na kha inge anma ni lifetime ma khan a trend da kha adang lam na te khan hu ni chu kan ecosystem adang lam na te kha mo kan ecological khami intactness te kha adang lam na te kha an hu ni chu khang wang te khanin an ni chuan an perception kha lo positive de zok the chu wang chu ni the chuan a thalai zok te khan an du lo te na chan chu kan economic stability tu na hana chiat lu tu wang ani them I na te awanga e zon na wanga livelihood a harsani chu khang tiang wang te kha ni them ti ang chi zong te kha kan en tel ve kani chu wangin conservation te environment sustainability kan ti te hianin I khang zong kha atila ni ti hi in shat ka dwa I heta I thingphun ro I tuin ha hum hal ro sakap su I mai ba ka khan beyond that kha atam lu tu kan ti kha in shat ka du wa in chu karon soi bo kan ani chu chan I enge hey heta puhanin I studies tam taka benefits more hemi forest communities then benefits an nei lo chuan an perception conservation at tan an perception kha I a positive thelo ani benefits an nei ve ngai a chan chu khang kha het kenin het a khopuya changin khatlai in ram kha I protected area nya kan hum halani kan vati ringwata amaro chu anni kha chuanin an livelihood an e zon na te an e na te I khatyang ang te ani awang khanin I kan ngai to tel vek angai ni an ma ni livelihood te khati te kha ma se a sustainable zone in ani turani ti te kha one health approach pek khalan ya chu bang chan chu kan soitel du ni chu in low contribute the in low ngai to zel the nan chuan soitur kalanga lu tu ka masedar card khatani doning te sha chuanin ka du to be anga so I would like to end on this note that by promoting collaboration across all sectors and by contributing from each of your branches of studies, a one health approach can be best achieved, can achieve the best outcomes for people, animals, and plants in a shared environment, and we can create this sustainable environment so that so thank you for listening, and thank you for your time.
Yeah, thank you, our resource person, Dr. Lilian Puikolni. I think before we begin the next presentation or the next invited talk, we should open a few minutes for question and answer or any discussion. If students have any queries or any clarification or something you need to ask from our resource person regarding Wildlife Institute of India and all, you can just unmute yourself, or otherwise you can type in the chat box. And in the meantime, I think our principal is still here, Professor Azel Tanzara. Sir, are you there? He was there in the among the list of participants.
Sorry.
Our principal, sir.
Sorry, sir.
Oh, sorry, just kidding. Yeah, anyway, I think he is no longer here. Maybe we can invite him later on. Yeah, if you have, if any of the student has any question or even the faculties, you can discuss it. I think we can open a few minutes for discussion. I think in the meantime, while you are thinking for what to put forward as your queries and all, there's something I have read in the news. I think it was 1 year ago. I read it in what was that? Daily Mail. It was regarding spotted and golden colored zebras in African plains. So it was written there in the news that those spotted and golden zebras are becoming infertile also. So they lose their fertility and their population was declining. And I mean, the normal striped zebras, out of those normal striped zebras, among the herds, there are like some form of sort of defect or deformed birds, actually, golden and spotted zebras. And I read in that news that the study, according to the study performed by one of the, I think, US universities, that such kind of deformation in those zebras, it was due to a kind of thing like, what is that? Lack of genetic diversity and inbreeding. And it was also written that it was because of this habitat fragmentation of those wild animals. So along that line, I think a few weeks ago, a few days or a few weeks ago, I read in a newspaper somewhere in Mizoram. I don't remember exactly which animal it was. In certain area, it was reported that there was some sort of birth defects in certain animals. I don't know if you have read that news, our resource person. I have read it somewhere, whether in the WhatsApp message or newspaper, I don't remember. Somewhere in Mizoram. So such kind of like birth defects, is it also possible that due to the such kind of lack of genetic diversity already? Because this is something which crossed my mind when like you showed I think the second or the third slides regarding what is that, the satellite images, so satellite image of India in 1992 and 2009, I think. So because of that encroachment of like wild animals habitat by the human population and all. So are we like in Mizoram also, is it possible that such kind of problem may also happen in Mizoram? Any study regarding that from
Uh,
your side?
Yeah, I think that, yeah, habitat fragmentation, it's it's usually due to agriculture, developments, and also this linear infrastructure, which we call. That's actually an interesting study done in I think North America. In my last presentation in PUC, I actually mentioned that study as an example. Actually, it was in the biotechnology department. So uh, uh, so a road that is cutting through has cut an intact population into two. So after a few years, no difference was found, okay, in those two populations. But when they look at the genetic this thing diversity of it, then they found many differences in those two populations in just a few span of a few years. So yeah, those kind of things are very much relevant. And also, I think in Mizoram, we do a lot of doom farming, shifting cultivation. We don't use our farmlands for more than a year or two. So I think that this habitat fragmentation, if we actually really look into it, because there are no studies looking into it right now, I think there will be a lot of maybe, even mild to serious consequences that we do not even know of now, but that will be there. So it definitely will be there, looking at the frequency of how we are doing that. Yeah, so I think that's a very relevant question, actually.
Yeah, I believe this is something
Yes.
a very good scope for, I think,
Mm,
studies,
yeah.
research as well.
Mm.
So if any,
Uh,
yeah,
Mr. Chairman, can I ask?
of course, yeah, please go ahead.
Yes, Miss Lalani,
Mm.
that actually was a very interesting presentation. I really appreciate it. I'm also working on the antimicrobial resistance of the bacteria, which were isolated from the dumping site, which is
Okay.
in Perial airfield. Before
Okay.
this, the waste were segregated. Now, all the waste were segregated properly. The samples, the sediment samples of that waste dumping ground were collected, and we have isolated few bacteria. And from there, we are very much surprised that we got like so many antimicrobial resistant bacteria. So some of the bacteria are like resistant to more than 10 and different antibiotics. So that
Yes.
is before the segregation. Okay. So what really surprised me is that when you present that the bacteria from the wild animals, that elephant, uh, there are some antibiotic resistant bacteria in that elephant. So
Yes.
what sample you have collected, like for isolating the bacteria, the gut microbes, or
Yeah, we're using fecal samples,
fecal
because
sample?
because that's the easiest thing to use, especially in wild animals, because it requires a lot of permissions, and we can't do invasive sampling.
Yes.
We're working on rhesus macaques as well. We're working on leopards on that. We're working on vultures. We're working on hornbills also. So we
Okay.
have very interesting results. And I think this makes it the situation of antimicrobial resistance more alarming.
Yes.
And
Yes.
I think that, considering the rate at which it's alarming, we do not, the common man do not have awareness at all. Like, you know,
Exactly.
so I think
Yes.
that this is really something that we have to look into and see. I mean, I think, yeah, like they used to say, we probably would get wiped out by antimicrobial resistance and all these things that they, many researchers used to say. But I don't think that's an exaggeration at all, because like I said, it's all a matter of One Health, because the interface between wild or free ranging or whatever is so close now that everything is intermixed. Disease transmissions, we are at that stage where we really have to pay attention to this and think about this, and how to actually not only mitigate or prevent these transmissions, but also educate the public. I think that's really important.
Yes, thank you so much.
I have one question. Not question, actually.
I'm scared of sir's question. He will ask me a difficult one.
No, I'm not asking the question. And even I find it very interesting, your presentation. And I find it's flawless also.
Wow. Thank you.
Actually, I heard you say that you have some students, even from Mizoram, in your presentation. Am I right?
Yes, sir. Those two, the study in Dampa currently, I had 2 MSc dissertations working on it. So they were working on that and they have done their work. They are graduated with their master's degree from WII. And actually, sir, you might be surprised to know that I actually had an intern from PUC. So yeah, yes. And now she has stopped, but she was there for us for quite some time, around 3 months.
Okay, very good, very good.
Helping in camera trapping, collecting samples, and doing analysis. So she was there with my researchers in the forest.
Okay. Can you please enlighten us a little bit how we can enter in your institute? Especially for the student, like BSc students, we have BSc students and MSc students among the participants. Just a brief, maybe not in detail.
Okay, so we have an MSc course and we have a PhD course as well, which we stopped for a year, but now it's going to start again. For the MSc, we used to have this wildlife course and this heritage and conservation course. The students are taken in every 2 years. So now if we're going to start a fresh batch will start, and there is a written examination that is involved, and after that we have an interview. So all those who are shortlisted for the written exam have to go through an interview, and those students are selected. So for heritage and conservation course, in the last session, there was a seat for 10 students, and for wildlife science, there was a seat for 20 students. And there are also some internal scholarships also that are available, depending on how well you do the exams. And for people who have passed out their MSc or even BSc, WIHAN project taka omrega ni ang tiklay po han advertisement o makan website in N1 research assistant kanti ang si BSc level atanga idil the atanga heta postdoc ang si ang tepo kha project scientist ang si mo scientist on contract ang si ang kha katiang khenga dil the kha oma ang tiklay po na top anime so atui laute an tui dana zirte in project ka hange ka fitang ti ta chanchu kan project ni te po hi faculty zir khana inang lo lu tu kan ya chen chu community work to pantia chen chu he enge engtinge ka tiang hemi research oriented tuk ni lem lo ang chi te khan omve bokta hemi conservation lama mission ang chi vatan pui mo ka tiang chi te achen chu he ganga project kan tiang chi te khapo kha kan ne ta kha tiang water species amo kha tiang ang chi fresh water kha tiang ang chi atui te po kha tiang khanan dil thenga. Then we have marine species atui te tan kha tiang ang project te po kha omve le zelta chuan he sakei te chu soilo lumanita WIA tan chuan in he amphibians frogs ti te khatiang reptiles ti vel tui tan po khatiang project ti na tu kha a omve zelani chu atlang puin I enge heta PhD ron ti du te chuan an master zo han enge mo project an mani fit in ber tur khanin anon deal phota ikhanan han thoka swanin I an guide tu ten han bekwalan zunga tian tlang nel huwa ti chuanin I khanin PhD entrance khan pe velia interview velia chuan khatiang tho khan chu ti chuanin enge an project chunga an supervisor tena tenena in rem siamna a oma khatiang anga project ina accommodate theini ka chuana tha an mani scholarship an nei ni chuani na tha ani lo chuanin enge an mani funds ten raise ve chin project te ziakin mo concept note te ziakin.
Thank you very much. Very informative lutuk ringot. An lom lutuk.
Oh, and if anyone needs any help, like I've always said before, I'm there always, like a phone call or WhatsApp or email. Like, you know, if anyone needs any advice or any help regarding this, please do feel free to contact me.
One quick questions. One quick questions. It's not about questions. Lala, can you please elaborate what is the importance of the presence of tiger in Dampa Tiger Reserve Sanctuary? I think this would be the right time, you know, to. Yeah.
Okay. So, you know, we have something that are called apex predators, right? They are okay. Oh, apex predator kan ti angka kan neta ni food chain kan neta in 8 hong khai dia angka kan neta kan shifek ta class 12 pa ti chuan kan zir ta theng chuan sang khatiang han apex predators kha an nita ni sake kha khanin apex predators anom hianin thil tam ta ka maintain ve ni entina historically in sake lo om to na china nita hey kan han soi thui deu zwayanga arei lowang o entina na hundanga chuanin hey sake le ke te mo leopard kan ti ang chi te le khami aya sake le chhongte omna landscape anga chuanin nichina ka soi activity pattern ang te khan zir china ni chu khang khan anin avoid vm sake active berlai kha leopard khanin avoid them ti te kha engting and overlap mo engting and resource use and overlap resource omja chu an so tina ni chu an prey species te kha an man dan kha in overlap them an time an man dan kha in overlap them ashangem ti te kha thil tam ta khan zirani chuanin kha khanin hemi khami ecosystem a khanin omja kha anei ta bekani achan chu soile soinu nichina ka soi angkha angulate ang tipo he mizo chuan sake cho kan ti meta ma se khang ringot khan ni lawa an mani in rule an nei ve ni chu chu a in thapung anga chu chu in thapung chuanin chu chuan ei turani chu miza chu sake chuan kum khata e yanga ya atlang point chu miza chu chozonan huna mangchin ti pe khatiang kha om ta vekta kha angkha atlang point khami apex predator te an om lo khan khang kha a in tear down china ni chu khami a in khai dia ta kha chu wa chanin an om kha sake an om hi apoi mo em ani chu mei ba ka enge thil a health of the forest more a forest a healthy empty determine nan khanin apoi mo bok ta ni chan chu an lo om to na china ni ta chu wa chanin khang tianga tan te khanin an poi mo a chu ba ka chan sake hi soile soi nu enga tinge poi mo na kan pek mem kan ti chan obviously charismatic species anya an ro puya mo kan ngai sang mase khami me ba ka khanin umbrella species kan tia umbrella chan tia na khwap vek ta khang khan species te zok ti meang neb zok ni loin mo species te zok kha sake te hian an conservation hi enge umbrella angin sake kha omani chu sake khanin ava protect tina angani chu tuna po Dampa Tiger Reserve te po Tiger Reserve ani na hianin enge asumang zong pon sumten don bel pha protection te tha enge manpower te hire na tu te thil chang logistics infrastructure ang chi angle thil poi mo ang chi mo equipments te khatiang te po kha sake khana ron pe timeang chu wanjang kha khan pui mo te tuna po Dampa khu Tiger Reserve ni lota se tuna din hun ang khwan om kherangem tuna protection mo ang khu ang kherangem ti kha in zo tham kha ni ta ni chu ta chuanin sake aya sate zong zong le adang biodiversity dang zong zong regardless of animals or reptiles, plants theng trees theng khanin andong tavek metani chuwa chang khamitan khanin an poimo sake ya le tiger reserve kan nei ve shima po himo hizo na ka changin
So
Thank you.
Yeah, if there are no other question, I think we can move on to the next session. I think that was a very
thank you so much.
Okay, thank you. That was a very interesting talk. I think I think we had a very fruitful discussion session also. So once again, I thank our resource person on behalf of the organizing committee. So I think we now move on to the second session. The resource person for the second session is Dr. Krishna Roluopuya. So they both are actually inspiration to many, I think, many students, many young students. So as I think some of you might not aware, here before I invite him, I would like to point out once again that Dr. Krishna Roluopuya was MYC Young Achievers Awardee back in 2018. And he grew up, I think he was born in one of like the village in Longkai district, Mualbu, I think, yeah, if I pronounce it correctly. And he was doing his elementary education school course while he was a student in Baptist boarding school. He also participated in 2005 National Science Children's Science Congress. There he presented his own research, his own studies on what is that? Yeah, regarding the use of water in their boys' hostel and all. So that was a very, very interesting research at a school level. And he was awarded A++ grade as a school student also. And one thing I find very interesting about Krista is that while he was a student of class 12, in Aizawl, he was engaged as a teacher for higher secondary school students, right? If I'm wrong, please correct me. He was engaged
I was in BSc, while I studied BSc.
Okay, yeah. But while you were waiting for a result, also you were a teacher in BZ Higher Secondary School.
Yes.
So just imagine if you just finish your class 12 when you are teaching your juniors again. So I think that's a very big achievement, and I think that tells his story. I mean, so he was a undergrad student in Zitiri College. Also, he was a teacher, and later on, after finishing his BSc, he spent 1 year in preparing and also earning money for his further studies in IIT Bombay. So he has now completed PhD from IIT Bombay. After that, he did 2 postdoctoral courses, one in IIT Bombay and another one in University of Arkansas, United States. And he is now currently working as assistant professor in the Department of Physics, Banaras Hindu University. And we have known each other for a very long time. If I remember correctly, the first time he visited our institution was in 2011 or 11, 12. I don't remember. I think you came along with Dr. Zodin Moya. And we met for the first time in our college canteen. And we have been friends since then. So it is we are, I think we are very fortunate to have him as a speaker for this session. And his research is mainly on nanotechnology, working on nanotechnology with certain sophisticated instrument like molecular beam epitaxy and all. So I think we should now invite him to deliver his talk. Yeah.
Okay. Thank you so much for a wonderful introduction, which I actually don't deserve. And Sarshad is one of our teacher who inspire us a lot, especially in physics community among the themselves. Actually, well, I was asked to give a talk, so I was thinking which topic I will, deliver. So when I look at the title of the webinar, meaning basically, it's a international webinar. So I was just thinking, if I can pull out one of my paper and give a talk. The same paper I gave a talk recently, just 2-3 days back, in one of the IIT's physics department as a faculty talk. And some professor asked me, they said, this is boring and we could not understand. This is some, it's not a topic. But I don't have any, I don't have any time to change my topic. I feel kind of very uncomfortable tonight, but I'll try my best, just trying to communicate to you what I'm doing for some, particular project. Before I start, I'm in Banaras Hindu University. So if you guys wanted to come here, so you can come as a graduate student, undergraduate student. So there are, a whole lot of disciplines, and you can come as a master student, and you can also come as a PhD student. However, there are some sort of entrance exams, which recently, which was recently conducted. So actually, we used to, publicize the date and the timing of all those, entrance exams. So hopefully, let's hope that we'll communicate in the next entrance exams again. Yeah. So, okay. So last time I listened to one of the talk, given by Sir Wanpuya from physics department. He was giving a talk in, I think, Lumley Kaufman College, and he was talking about semiconductors, basically at the, popular level talk, and I find it very interesting. But however, I would not be able to deliver the talk in that way. See, a semiconductor is something, very important, and, research-based high production of semiconductor device can make someone's country very powerful, economically, politically, or, in terms of, let's say, security as well. Think of United States, think of China, think of Japan, think of Russia, think of Taiwan, Korea, so on and so forth. So semiconductor is really important. So if you look at your mobile phones, if you look at your laptop, so on and so forth, whatever gadgets you can see around you, they are made up of, semiconductors. So, but actually, if you trace back the timeline when all this gets started, so basically, the world tried to understand, the importance and, the importance of high production of this, semiconductor devices in the late 1980s, and, some people get started. And unfortunately, during that time, India missed the semiconductor bus. So as for the moment, we import everything, and we spend billions of US dollars every year. Okay, so see, the policymakers, not only the researchers, not only the academicians, so on and so forth, they were very, you know, they were very, like, they know clearly that they missed this semiconductor buzz, and they want to revamp, you know, this production of high volume semiconductor device. So several important steps come into picture. One is, you know, establishment of this semiconductor fabrication labs, world-class fabrication lab in IIT Bombay and IC Bangalore. Okay, so they established this in 2006 under Ministry of Information Technology, and budget is also huge. And you know, I did all my PhD, my master's thesis as well here, and I stayed as a postdoc as well. So yeah, I bring this into this slide just because I want to tell you something about this. So in this semiconductor fabrication lab, known as Center for Excellence in Nanoelectronics, there is one program called INUP, I2I. It is Indian Nanoelectronics User Program, Idea to Innovation. So under this program, anyone who is interested, like he may be a student, a researcher, faculty, so on and so forth, he can come and participate in the workshop, in the seminar, in the conferences, and he can come and do hands-on experience. He can get trained with the state-of-the-art facilities there in the lab, and they can also write the project, and they can work there for 6 months, if I were not mistaken, maybe more than a year as well. So recently, they have made an announcement where there will be hands-on training workshop on fabrication and characterization of metal insulator metal, or simply metal oxide semiconductor capacitors. So actually, these are the two important building blocks of semiconductor device, and someone needs to understand it clearly as far as semiconductor device is concerned. Okay, so someone can apply. If I were not mistaken, the last day would be 17th of March. Okay, you can apply it immediately. So these are some of the universities and institutions, and some of the even some of the communities who come there in IIT Bombay, who go there in IIT Bombay. Sorry, not come. I was not there anymore. So this is giving a location tag for people who participate in this INP. So hopefully very soon, people from Mizoram University or some colleges will come here and do the stuff in IIT Bombay. So yeah, this is the thing that I would like to mention before I start the talk. But recently, the government of India made something very big news, which is floating all around. And in fact, this is something which is just waiting around the corners. And some of my professors, they are also working on it. They used to go to Prime Minister's office and try to convince and try to tell them what is the importance of semiconductor for India. We have this much quality researchers who can handle this. We have this much manpower. So if we can build semiconductor fabrication lab in India, so we can save this much money, so on and so forth. So India announced more than 20 billions, which is 153,750 crore rupees. This is huge. So they invested money this much for semiconductor research and production in India. Okay, so we can be part of this. So what I'm trying to say here is that if you guys were interested in semiconductor physics, you can come along. I think there would be lots of avenues and opportunities. There are many important results that are just waiting around the corners, so we can work together. So yes, now coming to the talk. See, Sarwanpu and Sarsheta, I think they will be very aware about these semiconductors materials. So I used to have colleagues or some even students who used to ask me, why are you working on group 4? Group 4 are those materials like silicon, germanium, tin, lead, so on and so forth. So because this question is very relevant, because people have gallium arsenide and gallium nitride system, group 3, 5, semiconductor compounds and gallium nitride system compounds. So, those have a high mobility and, they have reached a high level of maturity as far as semiconductor device is concerned. Yeah, they are okay. But however, there is a problem. See, if you consider your, if you look at your your mobile phones, everything is on silicon chip. Everything is on CMOS platform, silicon CMOS platform. So the point is, like, if you have a device or which you want to transfer information between two transistors, suppose you have a photodetectors or a waveguides or maybe even lasers which are made of 3,5 semiconductor compounds, there is a problem. The problem is that those semiconductor device, when you integrate on silicon, they will act as a dopant. They will contaminate the substrate. So basically that will degrade the performance of the whole chips, basically. So the point is, if you can have photodetectors, waveguides, lasers, so on and so forth from the same group 4 materials, then things would be, you can circumvent those problems. All right. So in the recent year, a particular group 4 compounds or alloys, I can say, yeah, germanium tin has, been in recent news, and there are a whole lot of people who are trying to understand this particular compound, because when you alloy germanium with tin, so basically you can engineer the band gap in such a way that the band gap of that materials will be lower than the pure germanium. So basically tin is a relatively less known semiconductors. It has zero band gap. So basically when you mix with germanium, when you mix the atom of tin with germanium, then basically you can manipulate the band gap to a degree which is lower than the pure germanium. So yeah, this can be very promising. In fact, people has already proved that they can build lasers, meaning they can show that this has a direct band gap. Actually, recently there was a publication from Germany. So yes, people are trying to come back to the same group 4 and trying to work on integrating this group 4 semiconductor device on silicon CMOS platform. This field, popularly known as electrophotonic integrated circuit, has seen a tremendous research effort in trying to build these semiconductors which are made of group 4 materials, to get integrated on this silicon chip. Yeah, and in India, as far as semiconductor material is concerned, you can see a whole lot of people who are working on gallium arsenide, gallium nitride, so on and so forth, and there are lots of facilities. But as far as group 4 is concerned, I think IIT Professor S.K. Rai in IIT Kharagpur, he is working on silicon germanium. However, he got shifted to Indian Institute for Cultivation of Science as a director. So it seems like only IIT Bombay, like where I was doing my PhD, is the only lab in India where this kind of research is going on. So see, India is still importing a whole lot of wafers from Israel and France, meaning these group 4 wafers. So if someone can have this sort of expertise where they can grow group 4 semiconductors, this will make a lot of changes. Yeah. Now, so these are the instruments that I've used for producing this result. Yeah, this is molecular beam epitaxy. No, sorry, this is I haven't used this for this particular work. This is in the United States, and this is a high X-ray diffractometer, and this is a fabrication lab in IIT Bombay, and this is high resolution transmission electron microscope, where you can see the semiconductors materials at the atomic level. Okay, so one of the paper that I have pulled out is germanium tin epitaxy on gadolinium oxide. okay, which is on silicon. So see, the main problem with the group 4 semiconductor material is that, you know, since they have a very small band gap, just 0.67 in case of germanium, if you add tin, it will be more, it will be lower than even that. So the problem is they have high leakage, you know, current, and basically it means noise will come into pictures. So see, if you consider this this system, okay, this is your germanium tin, let's say, or germanium whatever, these are group 4 materials, and you have a silicon substrate. Suppose if you shine light here, photon is coming, and you know, electron hole generation can take place even in the substrate, because if you consider 850 nanometers, so you know, silicon have absorption length of more than 15 micron. So these electrons and holes will take a lot of time, you know, to come to the electrodes. So basically it means this will degrade the performance. Basically the bandwidth will be, you know, degraded. So one thing which we are looking at is that if we can have insulator in between the two semiconductors, so basically you are going to separate these two semiconductors electrically, meaning you will whatever is generated here, supposing even if a photon can go through these insulators, let's say, just because of the electric field, displacement component will be there basically. So it will never travel back to the active layer just because it was blocked by the insulators. So in fact, this is the first demonstration of you know, germanium tin epitaxy on, you know, insulator substrate, in which you know, all the layers are, you know, epitaxial single crystals. So it means that I have single crystal here in silicon, and even the insulator itself is also single crystal epitaxial, and even the germanium tin is also a single crystals. So see, there are many you know, there can be many semiconductors materials sitting on insulators, but insulators in most of the cases, they are, you know, amorphous. So they were, you know, basically fabricated by using, you know, this wafer bonding, which was a very, you know, complex process, and huge amount of manpower and energy, so on and so forth, are required. So in this case, we demonstrate by using molecular beam epitaxy. So this is simple details. I don't know whether I should include this or not. Actually, that insulator substrate were grown by, you know, one of our collaborator in Leibniz University in Germany, and was shipped to IIT Bombay. And some routine degassing was done at 180 degrees centigrade for 12 hours in the load lock chamber of the molecular beam epitaxy. And heating was done just to, you know, to remove all the volatile materials, just to have surface reconstruction, just to make sure that our surface is clean for putting the atoms over it. Yeah, and we have grown 2 samples, in fact many samples, but here I, you know, pull only 2 samples. They were grown at 190 degrees centigrade at the rate of 1.6 nanometer per day. But however, I want to I wanted to, you know, tell you one technical term which was very common in group 4 growth community, like especially in molecular beam epitaxy. One technical term. See, if you look at this, this is a gadolinium oxide, and this is a silicon. Gadolinium oxide is sitting on silicon. All right. So these are the atoms. All right. So if you look at this arrow is normal to, you know, silicon minus 111, and this arrow is normal to gadolinium minus 111. So basically, if you rotate this by 180 degree, you will have the same kind of, you know, arrow here. So basically, it means this is symmetric if you rotate it by 180 degree. If you consider this as a mirror plane, sorry. So this is the mirror image of this. So basically, this silicon is called type A, and this gadolinium oxide is called type B. So the epitaxial relationship will be like this, meaning basically they are rotated by 180 degree. So maybe I'll mention this frequently during the talk. So yeah, one of the biggest advantage of having molecular beam epitaxy is that you can have in situ measurement system. In our case, we have reflection high energy electron diffraction. Here, the diffraction, the mechanism of scattering is also elastic one. So the diffraction pattern can be cast into the geometrical construction of the Ewell's fields. So basically, it means that if you have a flat surface, if you have a layer of atoms which are very flat, okay, you're going to have reciprocal rods in the reciprocal space. But if you have some sort of islands, then basically you are bound to have this sort of spotty pattern, which is demanded because it is a transmission spotty pattern. All right. So yeah, so these are the two data which we did in our lab, but it was not published. Okay, so this is my silicon and this is my insulators and this is my germanium tin. So basically it means I have silicon here, and on the top of it, our collaborator in Germany, they have grown insulator, and on the top of that we have grown germanium tin. And here I have put two samples which were grown at different thickness, just to make you sure that you don't miss some of the points that I'm trying to convey. So this is the read image just before the growth, meaning after heating it for 700 degrees centigrade. Coming to that particular temperature was also a little tricky. One has to do some calculations and repeat the experiment many times. So we have a surface reconstruction here. Yeah. Now, when we started the growth, meaning when we put the atoms just on this insulator substrate, so the signal to noise ratio gets reduced, meaning get worse. So this is because of the presence of some oxides. So after 5 minutes of growth, you have some sort of spotty pattern. I told you when we have spotty pattern, we have some islands. So this is basically telling you the onset of island formations, characteristics of one growth mode, which is known as vulnerable growth mode. If you look at carefully this one, see, you can, if you take these central reciprocal rods as the mirror image, you can superimpose this spotty pattern with one another. You can superimpose this over this, so on and so forth. So basically here it means that this is telling you, okay, that there are two types of islands, which is growing in the directions of silicon as well as in the direction of gadolinium oxide, meaning there are type A and type B, type of kind of germanium tin. However, after 3 hours of growth, one of the two superimposing pattern gets reduced, and you have only one spotty pattern. Let's say type A. Okay, then after 4 hours, we have reciprocal rods. So basically, it means that two-dimensional growth get recovered after these 320 nanometers of germanium tin growth. So this is a live, a real-time monitoring of the growth for this sample B, not for sample A. However, it is the same as this one, but however we stop the growth before this, okay, before this happens. So yeah, now coming to pole figure analysis. So actually when you arrange atom on the top of some of the substrate, so the point is there is going to be some dislocations. So one atom will not sit exactly above the other. So to quantify this globally, you can have one very powerful instrument, that is X-ray diffractometers, and in that system you can have pole figure measurement. In pole figure measurement, what you did, you have this reciprocal lattice vectors which is pointing in these directions. Yeah, so this means that you can have a phi scan at different chi angles. So when you change the chi, basically it means this reciprocal lattice vector is moving at different directions, where you can scan from 0 to 90 degrees. Yeah, so this is the wide omega 2 theta scan. we need to confirm and we need to make sure that we have single crystals. So to know whether it is single crystals or not, we have to perform this white omega 2 theta scan. So here you have germanium tin 111 reflections. So this is the tertiary reflections. Basically, it means that you have only one reflection, which is a multiple of just if you have one family of germanium tin reflections. Sorry, yeah. So basically, it means that this is single crystalline. And the other thing is when you let the atom sit on the other materials atoms. So basically, since the atomic radii, can I mute? Yes, thank you. So when you sit one of the species atom on the other species, basically since the atomic radii are not the same, so basically in terms of condensed matter physics, since the lattice constant are not the same, so basically you are going to have some kind of strain built in the epi layers. So just to check whether you have strain layers or not, you have to perform this kind of skew symmetric scan. So we have done this skew symmetric scan at different chi angles, and we just come to found out that we have the same lattice constant at different in-plane angle. So basically it means that these epi layers is or are completely relaxed, meaning there is no such thing as strain energy built inside the epi layers. So yeah, this is the Paul figure analysis. So if you look at carefully, these are the triad S1, S2, and S3. And this is S0. So these are basically coming from silicon 111, silicon minus 111, silicon 1 minus 1, silicon 1 minus 1. So basically this is telling you the reflection symmetry of cubic silicon. Yeah. And if you look at this, see, we have done this. I have done this Paul figure measurement at the Brecht's angle of silicon 111, basically, which is somewhere 24 point something degree. Maybe I wrote somewhere here. No, I haven't. It will be around 24.5 degree to theta value. Yeah. So see the gadolinium oxide is lying very close to silicon. Sorry, I'm doing this on silicon. Yeah. So this since these two reflections superimpose each other, basically you are going to see the same reflections when you measure only for even silicon 111 reflection as well. So this triad is basically giving you the same threefold symmetry in cubic bis-byte structure of this gadolinium oxide. But see, there is something very tempting. If you look at this carefully, see, I said this is rotated by 180 degree. This is the schematic diagram. See, if you consider the difference between these two spotty pattern angles, just 60 degree. But see, if you try to quantify a particular angle for this each Bragg spot, so say for example, if you consider this to be gadolinium minus 222, minus 222, and this will be silicon minus 111. So if you count how much angle is between these two spots, then it is going to be 180 degree. So basically it means that these two triangles are rotated by 180 degree. Okay. Now coming to germanium tin, so we fix the Bragg's angle at this germanium tin 111. So basically around 24. Yeah, and then what happened? We have seen the same hexads. Okay. So basically we have seen, basically here it means that we have a silicon, we have germanium tin, which is following the growth directions of silicon as well as the insulators. However, it is interesting to note that type A germanium tin has more intensity than that of this type B. All right. Here you have seen another triad. I presented here symmetrically. Yeah, this is basically due to some reflection twins, but not the rotational twins, which I'll show with some of the with the electron microscopy image. So basically you can take this to be reflection twins. which is making an angle of 38.9, taking, germanium tin 111 as a global plane. Yeah. So you can have, you also have another 3 triads, basically, which is, which is symmetrically similar with this GTO, okay, which where one of the piece lies outside the detection range of this Paul figure measurement. Yeah, so this is the same as this. So basically what I'm trying to convey is that they are also a reflection twins. So basically here it means that these are the reflection twins, which is making an angle of silicon minus 111, taken that as a global plane. Okay. Now just quantify how much percentage of type B is present in that type A germanium tin. So we have done this Q symmetric measurement. So we have done the calculations, and it turns out that some 2-3% of type B germanium tin is present in that type A germanium tin. So basically it means that we have 2% of germanium tin which is growing in the same direction of gadolinium oxide, whereas the other 98% are growing in the direction of silicon substrate. Yeah, this is the last slide. Yeah, so this is for sample A. This is the image of transmission, high resolution transmission electron microscopy. So you can see that this is flat. This is in this is consistent with whatever you find with the read image. So but this for sample A, meaning just 210 nanometer thick germanium tin, you have some sort of rough surface, some sort of islands. Yeah, and if you look at carefully this figure C, this is showing you a representation of a very close high magnification image in between this germanium tin, gadolinium oxide, and the silicon. This is germanium tin, gadolinium oxide, and this is the silicon. So if you look at carefully, I told you in the beginning, we have this arrow which is pointing in the direction normal to silicon, minus 111, and this is, arrow is pointing in direction, the same, crystal planes. So if you look at carefully, this arrow and this arrow, they're pointing in the same direction. So it means germanium tin and silicon, they are growing in the same directions. However, I told you in that global study Paul figure measurement analysis, we have found that there are some few germanium tin, maybe of 2%. Yeah, I'm not very sure. This was done in 2018 or 2017. I think I can mute. Yes, thank you. So yes, but unfortunately I could not track those type B germanium tin. But here it's interesting to find that we have some sort of reflection twins which is making an angle of 38.9 with respect to this global silicon or global germanium 111. All right. So yeah, in the device part we have fabricated, and I've shown this IV dark current measurement. So if you look at carefully here, we have fabricated. I have fabricated device. Okay, photolithography measurement, etching, so on and so forth, developing. So here, this black one is giving you, the IV characteristics for germanium, which is directly on silicon. Let's say silicon, yeah. Though I have germanium in between, meaning all these layers are semiconductors. But when I have insulator in between these semiconductors, the dark current get reduced. So what message is, so I can have some message out of this data. It means that those of the carriers which are in the substrate are not coming all the way to the active epi layers. So basically I block those layers which are generated, let's say somewhere in the substrate. So basically when you have less dark current, basically the performance of the device will increase. So yeah, that's it. Thank you so much. I know, I want to finish quickly because I know many of you will not catch up with me. I'm very sorry. It's not like the other night. If I have time, I could have prepared for some popular talk. I'm very sorry.
So yeah, Thank you, Dr. Krishna Rulopuya. I think for me, it was a very interesting talk for a physicist and people from electronics and other related backgrounds. But here among the audience, I think we have people from life sciences. So what I would like to ask a few questions. I mean, uh, of course, we will open for discussion. See, you have in your last slides, you have shown us that you have fabricated a device on such layered structure like germanium tin,
Yes.
one layer, another one is gadolinium oxide and silicon, right?
Silicon, yeah.
So you
Silicon
have
is the
shown the
substrate.
silicon. You have shown the IV characteristics.
Hmm.
So like what kind of applications will such device have? I mean,
So basically, actually, our whole intention was to fabricate photodetectors out of this. So
photo
basically,
detectors.
yeah, we want to go, more than NIR, short wave infrared, basically more than two micron. So yeah, just to check whether this will work or not, we have done some sort of IV measurement. And also, like recently, we are trying to fabricate MOSFET out of this, because when someone have tin in that alloy, so the carrier mobility can increase more than silicon or germanium or silicon germanium. So we want to use that as a channel for MOSFET.
So your photo detector device, your detecting device that you fabricated, in that such that the picture you've shown us, that's that the whole structure. What would be the dimension of it? The whole structure dimension,
It's
just for a layman. Yeah,
so yeah, the distance between the two fingers is 8 microns.
8 microns.
Yeah.
All right. See, something I would like to point out here for the audience is that what they are trying to achieve is they are trying to make a very like micrometer size, very small dimensional detectors, right? So nowadays, I think with the growth of this kind of silicon technology and other semiconductor technologies, our devices are getting smaller and smaller. And nowadays, I think most of us are wearing smart wrist band. So here in this kind of small device also there are plenty of transistors and such uh, micro devices are fabricated because of this kind of research that are being done all over the world in academic institutions and research laboratories. The technology of, for these semiconductors including group 4 elements. It's still evolving. And I think nowadays people are designing a transistor in 7 nanometer size also. So,
Yeah, yes, 7 nanometer node,
so 7
even 2
nanometer.
nanometer node technology is coming.
Yeah, okay.
People claim that they have done this. I think,
Yeah.
if I were not mistaken, from Intel.
I don't know if people from life science have seen it or not. See, before this semiconductor technology was developed, there was this thing called vacuum tube technology. So, in such vacuum tube technology, using such vacuum tube technology in 1940s, 50s, and all, people have IBM and all. They have designed the first computer also using such vacuum tube technology. So a single transistor will consist of vacuum tubes. That vacuum tube itself would be, I think, probably around, I don't know exactly, Krista might know, probably around 2 inches dia or something like that, 1 inches dia or something like that. So they used to fabricate a transistor, a device having, not a transistor actually, they are called triode, a device that can perform as a transistor in such a large dimension, 2 inch diameter size kind of tube. And for designing a computer, for designing a processor, and for designing the memory elements and all, they would require a number of transistors. For some of the audiences for life science, you know that like your memory device your phone memory and most of your electronic gadgets memory, they are relying on transistors, the on and off stage of a transistors. So earlier they did not have a semiconductor technology. They used to have a triode valve, and in such triode valve, they have an on and off stage of a triode valve. The off stage of a triode valve was recorded as, in digital technology, 0. The on stage was recorded as 1. So like in a transistors, the off stage and on stage of the transistors are denoted as 0 and 1 state. And therefore, because of these transistors, we have this kind of digital system, 1 1 0 0 0 1 1. So this kind of digital memory systems are deployed for designing a computer and our micro and nano devices. So I think it's very interesting. I think if you don't have any question, I think we can open for a question hour for a few minutes. And now it's almost 9:40. So if any student or anyone, any teacher also.
Sir Monpuya can give some, can say something. I think he can have a better picture of what I'm telling. Recently, he gave lectures. He gave a talk on semiconductor device. I know. He can say something.
Actually, Chris, I think I don't need to expand your speech because it's really nice to hear those small technology, which is very powerful. Anyway, your speech is very nice, and I'm very thankful that you are mentioning my name, even if even you are still remembering me. I know.
No, you were once my teacher.
Yes, I still remember when you thought about your own background and your problem in that Zirtiri college long years back. No, anyway, so yeah, regarding semiconductor these days, things are really growing very fast, and there are lots of research work regarding this semiconductor. Everything in this world means every devices. They are all based on this semiconductor. And tonight our speaker also talk about this how they are improving and making it smaller in size. We all know there is a processor in a computer. It's only 1 inch, 1 centimeter square. Within that, there are around 750 billion transistors embedded on it. But with the talks we have listened and with the improvement of the world, I think we will be able to carry like Core i9 is already there. Core i9 processor within our pocket very soon. So everything in this world, digital world, is growing very fast. And what I would like to mention is that for a science student or anyone here, if you are interested, this research work is very interesting. All the research work in semiconductor is very interesting. And what I used to say is that when we study what we can touch and what we can see, it is more interesting rather than like assuming and dreaming all these things, like we may trying to vision the things. When we study what we see and what we can touch, it's really interesting. So if you like to go and in this line, you have a lots of wide security, you can say, regarding job also in this line. So I would like to add some of that regarding that. But regarding the technical part, I don't think I don't need to say anything about that. And I'm very thankful that I just screenshot that the first slide, I think, not the introductory slide, the second slide. That will be a big thing for me. I will look into it, and even if I have the chance, I will try to go towards that line again because I'm very interested in electronics. So I will study about that INUP. Is that correct? That one?
Yes.
Yeah,
Right.
yeah.
INEP.
Yeah, all those things. I have screenshot it. I will study. I will read about it later on. Thank you so much, Mr. Chris.
Most welcome.
Dr. Chris. So I think that
Yes.
some of your your physics students that are attending the talk right now, I think it's important for them to know that, we're talking about sustainability and, the role of science and technology in that. And I think that the role of physics in that cannot be disdained. Because
Yes,
most times
exactly.
we think that is the duty of life science students or lifetime people. And in fact, the Nobel Prize in physics was also awarded to, climate scientists for their work in climate
exactly,
change.
recently.
And, so I think that, all these, yes. So I think that that way, it might, how do I say, uh, influence or encourage the students a little bit, just to mention that these physicists were working on climate change, and they did very, very good work and great work. So I just wanted to mention that.
Sorry, actually, I forgot to pitch on that. But actually, I identify myself as a nature conservationist, though I'm a physicist. Yes. Yeah, I find it really important. When I try to make any decisions, I'll think on go green or go protect environment, so on and so forth. Yes. Thank you for reminding me, and thank you for conveying that to science students. Yes, I appreciate it. Oh, I think Bernard is here. Bernard want to say something, I guess. Bernard.
Bernard Vanal Monpuya, I think he has unmuted himself, or maybe not. Okay. So I think I think these three technical sessions, I think it has been a very successful one, especially the ones we had tonight. So I think it is very interesting in a sense that one speaker is from life science, not exactly life science, yeah, wildlife, yeah, and another one is from uh, physical science, with a very interesting nanotechnology that are being developed in this R&D sector that is in the research, that is still in the research stage. Hopefully later on, in maybe in few years, it may come up in the manufacturing. So let's hope for that. And one thing I forgot to mention before I invite Dr. Krishna, is that he has already filed a patent for, I think, two of his research work. So,
Yes.
yeah, that shows that the work they are doing, they are something very relevant for developing future technology. So yeah, in a sense, I think this is also in line with our theme of this National Science Day, to develop new technology, nanotechnology, that will of course help us for a sustainable future. So once again, I thank two of our speakers. Before we conclude this session, I would now invite Dr. Zoltan Puya to propose a vote of thanks.
Okay, thank you, Mr. Chairman, and good evening once again. Good evening, everyone. On behalf of the organizing members of this international webinar, I would like to, first of all, thank our respected Principal, Professor H. Lautanzara, for his support and guidance for the success of this webinar. Thank you very much, sir. And a big thank you to our beautiful speaker, Dr. Lilian for your efforts to make a wonderful presentation. I think our students are very much inspired and enlightened by your great works and your experience. So thank you, Ms. Lalani. And I would also like to thank Dr. Krishna for a wonderful presentation. He's one of the best, I should say, in his subject in the current generation. So as mentioned earlier, he's having so much of exposure, even internationally. So I'm so grateful to the technical in charge, Dr. Mumpuya and Dr. Zautan Moya. They are the men behind the success of this webinar. And I would also like to thank the Mystic, our partner and sponsor for this webinar. Thank you very much. I think Dr. Davy is here. I'm not sure. Before he asked me the link for the webinar, and I've sent him. So thank you very much, Mr. Davy, Dr. Davy. And lastly, I would like to thank the coordinators, Sarmapuya, and all the assistant coordinators, all the participants for making the webinar a grand success. Thank you very much. Thank you all.
So I think with that, we conclude the official program of this international webinar. And I think now I can see that Dr. Davy is here, and also our coordinators are Dr. K. Vanal Dinpuya. I think we should invite Dr. K. Vanal Dinpuya. Sarma Puya, come on, lock mero. Sarma Puya, toy te hun gan peg lo chuan. Ama arrangement veganisia and Kim he. Ama ho gan ti vegania report a tool at yang te say to lo so mang. Do say to rin.
Okay, thank you so much, respected Chairman. And as our Chairman has already pointed out, this program was organized by the Research Committee of Pasua University College in collaboration with Mizoram Science, Technology and Innovation Council in commemoration of National Science Day 2022. And the organizing committee decided to set up a registration link where participants can register for the webinar, and altogether registered for this international webinar. And okay, that's I think that's all from my side, sir. And report to mystical in Mintea, Casars, Zepi Haron Sweet or Lomturon Sweet or Toa. Kabaksu and the Belvactor Omloa Zalina, Miss Lala Nile, Sar Christate, in Suak and Lom Taxet Zedani, into saying Nom Taxet Zeta in Suitra. Tinkan principal can top with the Tin can utilize on some te. Here webinar. Aflot in Tainana. In low attention of our hemi program song, Dianga can maintain in low in Pegna, I'm Pegna. Long to can say taxit the Kabaks are long to say to Conchetolo M. Can long taxits in the Baka. Can long taxits it.
Lo ome. Pudavia Kama say to more mystic lomotrain say to Rome more.
Oh, hello, sir.
Oh.
Kan me kamo hey motora katsuga. Oh, National Science Day may baga hian National Mathematics Day pola kan thilti turang khai kan la zit pola kan latia chuti rolin PUC lamin in program ate hey meron som lomom kan tiatin aber hi ni zia kumtin mai hian hey achangin kan plana hi aron eng dewa chai thim dewa milo the thiamula achangin signal te ron chede ulek mai thea info ni se kan somna te minti rodin saka hei ro pui tak mai international webinar te ino hoi hot thea inchunga lom thu kan soi tak mewa kumdanga te po pathian zara sipuite an kiam dewa asinga sange in kan ti theinge tura kanin dei se ani chung huna chuan du sakzong ang te po hei ati thaberin ni na nga kanin du sak tura te po ngai la ti kha ka soi thei to ni se mystic lama thangin lom thu kan soi tak me ni in malang na te aro pui kan ti kan chuang cheu thopui zel cheu po kan cha kani ti kha kan soi du ni ro me
la kini po kan lom tu ke in zara I think program no thing kan bot say ya lom ti khan kan chairman Dr. Lam Rinan soi tur nei lo chuan kan program hi kan du tok mai don mi nia hello me zaina